Hi students, how are you? This is Swapna, Mathematics faculty from EDUHUNT IIT and NEET Academy. Right, so today we are going to start a new session which is related to progressions. Right, and you may get doubt, ma'am, you said that we'll be dealing with a progressions chapter, but the title of the chapter starts with sequence and series. But what does this actually mean? So what is the relation between sequence and series, progressions, and how we begin with a sequence and series? Let's see a detail, right? Okay. So what is the first definition? The definition is a sequence. Sequence is nothing but a systematic arrangement of numbers according to a given rule is called sequence. So what do you mean by sequence? You will have some numbers, you will have some terms, you will have some letters. Right, a systematic arrangement of such terms is nothing but sequence. Am I clear? You just need to arrange. How you can be arranging? Either ascending order or in descending order. Right, yes. So let's see an example. Let me take a numbers 2, 4, 6, 8, 10, 12, 14, 16. So you have numbers which are arranged in ascending order. This is nothing but sequence. Right, you have numbers which are systematic, we are arranging in such a rule that the difference between these two numbers is nothing but 2, right? Sometimes you may have difference, sometimes you may add, sometimes you may multiply, right? Any pattern which follows and we arranged in a systematic way, the terms is nothing but a sequence, right? Am I clear with it? A systematic arrangement of numbers according to some rule, whatever they gave, that is nothing but a sequence. Clear? So let's begin with the next. So this sequence is actually related with this sequence is of two different types. First is finite sequence, second is infinite sequence. Finite sequence means what? Finite means which is countable. Which is countable. Which is countable. The numbers or terms. The terms are countable. For example, how the finite sequence, finite means we will have a last term of a sequence. The best example of finite sequence 3, 6, 9, 12 and full stop. And full stop. Right. This is nothing but a finite sequence. Right. So next point, infinite sequence means whereas in infinite sequence the terms in a sequence are uncountable. Uncountable. At the same time, you will not find a last term. We cannot say about last term, right? So what is how to express an infinite sequence? And in an infinite sequence can be 3, 6, 9, 12 and so on. You will not find the last term. Clear? So in an infinite sequence you can find the total number of terms. You can say, like, if I ask how many number of terms exist, you can say total number of terms, you can say. Right, but here you cannot predict how many terms are there. How many terms will be there? You cannot say. Right, we cannot predict. So this is the difference between finite sequence and infinite sequence. Am I clear? So here we also have a note point. What is that note point? If a sequence is given, for suppose if a sequence is given, then we can find its nth term, and if the nth term of the sequence is given, we can find the terms of a sequence. What do you mean by this nth term? Here you can find some new word. What is that? It is an nth term. What do you mean by nth term? What do you mean by nth term? See, let me express about nth term. Before solving some questions, I just want to tell you about its terminologies. For example, let me take an example 3, 6, 9, 12. This is a finite sequence because you can count number of terms, how many are there, right? First term is always represented with, what letter? It is always represented with a small a or equal to T1. T1 means what? The term which is located in the first place. First term, first place. Okay, T1. Second term, what is second term? How it will be represented with the second term? T2. T2, how it will be represented? Tell me. This is the second term. So, what is the T2 here? 6. What is third term? Third term. T3 is equal to 9. Fourth term. What is fourth term? T4 is equal to 12. What I mean to say is, if the particular sequence is finite sequence, if my sequence is finite sequence, I can say the number of terms. I can say how many number of terms exist. How many number of terms exist, right? And what about if you have last term? This is also represented as T4, and T4 is the last term of this particular sequence, correct? How it will be represented? First term, second term, third term, fourth term. For suppose if I want to express what will be the value of at the term of the nth place, how will you represent Tn? Tn means what? The term which is located in nth place. What is this nth term? For example, let me consider an infinite sequence. Infinite sequence. So what did you have here? The same example I will take, but you will not be ending with the last term. It will keeps on go on, right? And it is keeps on going, which is so on. You will represent with so on. Up to this, it is a fourth term. For suppose what will be the value at nth position? Let me take it is a nth position. So, and you need to find the value of the term at the nth place. How will you express? Tn. How will you express? Tn. So, in an infinite sequence, you cannot able to find Tn. But whereas in a finite sequence, you can find Tn. Last term you can define here, right? So, that is also a difference, right? So, next we will learn about, let me check with an example, right? Find the first 4 terms of the sequence whose n terms are given as follows. You need to find the first 4 terms of the sequence, okay? First 4 terms of the sequence. So, and this is the Tn, nth term also they have given, right? So, first, what I mean to say, T1, they were asking you to find first 4 terms, right? T1 is equal to, in the place of n, you need to substitute with 1. So, what is the formula? 3 plus 1. 3 plus 1, which is equal to 4. Next, what is I need to find? I need to find T2. T2, how need to find? 3 into 2 plus 1, which is equal to 3 to 6, 6 plus 1, 7. Next is nothing but T3. 3 into 3 plus 1, which is nothing but 11, correct? 3 into 3, which is nothing but 10. So, see here, 3 into 1 plus 1, 4. 3 into 2 plus 1, 6 plus 1, 7. Next, 3 into 3, 9 plus 1, 10, correct? T4, what is T4? 3 into 4 plus 1, which is how much? 13. And if I ask you to write down the terms in order, 4, 7, 10, 13, right? 4, 7, 10, 13. So, with the help of Tn, you can also find out, you can able to find out all the terms of a given sequence, right? So, next one is similarly, you also find T1 is nothing but 2 into 1 square minus 3, which is 2 into 1 minus 3, 2 minus 3 is minus 1. Next, T2 is equal to 2 into T square minus 3. 2 into 2 square is 4 minus 3. 8 minus 3 is equal to plus 5. Next T3 is equal to 2 into 3 square minus 3. Again 2 into 3 square is 9 minus 3. 18 minus 3 is 5. Again next 15. Next T4. What is T4? 2 into 4 square minus 3. In the place of n I am substituting 4. Okay. Which is 2 into 16. 4 square is 16 minus 3. 32 minus 3 is how much? 29. Right. Here the common difference is 4. So with the help of Tn you can simply find out the values of all the terms of a sequence. Correct? Understood? So this is nothing but sequence and its example. Sequence is nothing but an arrangement of numbers which follow some pattern or rule. Right? So I also told you about the terminologies. What are the terminologies? First letter is represented with the T1, T2, T3 and so on up to in the nth place you have to represent the letter with Tn. Right, with the help of Tn, if you have Tn, you can find out all the terms of a given sequence. Right, yeah. So next comes about series. What do you mean by series? I told you about sequence. Series is nothing but whatever the terms are there in a sequence, you need to add up all the terms. Right, you need to add all the terms, then you will be getting a series. So a simple definition, the addition of all the terms of a sequence is nothing but series, and it is actually represented with a letter Sn. Sn, right, means sum of all terms of a sequence up to nth value. Right, sum of n terms of a sequence in a series. Okay, that is nothing but series. Right, so let us show the example and differentiate it. Okay, so sequence means you have to separate it, you have separated by the commas. 2, 4, 6, 8, 10, this is following a pattern. Right, and you have separated by the comma. Whereas in series, what I am doing here, I am just adding all the terms like 2 plus 4 plus 6 plus 8 plus 10, which is how much? 2 plus 4 6 is 6 plus 6 12, 20, 30. So this is nothing but series. All the terms of a sequence I am just adding up so that I will be getting series of a equation. Am I clear? So let us find out one more example also. 1, 2, so on up to 100. So this is nothing but sum of first and natural numbers. That is already I have told you, the formula is n into n plus 1 by 2. What is n here? Up to 100 numbers you are adding here. So what I am doing here, 100 into 100 plus 1 divided by 2. 2 ones are 250s are. So 50 into 101, which is nothing but how much? 50 into 101 is nothing but 550. Am I clear? Am I clear with this? So this is nothing but an example of 101 into 50, example of sequence and series. Am I clear with it? So I already told you the sum of all terms of a series is nothing, sequence is nothing but series, and it is represented with the S suffix n. Clear? Chalo. So difference between sequence and series, just now I told you, set of all elements that follow pattern. Of course, in a sequence we will follow pattern, right? For example, 1, 2, 3, 4, 5. It will have to follow a pattern. Whereas in series, sum of all elements of the sequence. How do you define a series? You need to add all the terms of a particular sequence. Next, order of element is important. Order means, for example, you cannot write like 2, 1, 5, 4, you cannot write like this. Of course, these are terms, but it should follow some pattern. Either by difference or addition or multiplication, it should follow some rule. You need to arrange in a systematic way. Whereas in a series, order of element is not so much important. Why? Because if you take the same example, plus is commutative, right? So 1 plus 2 plus 3 plus 4 plus 5, which is nothing but 3, 6, 10, 15. it is same. If I add like 3 plus 4 plus 5 plus 2 plus 1, still it is 15. Right? Addition is always commutative. So, order is not that much important. So, this is an infinite sequence. This is an infinite series. You have a types of sequences and types of series, right? This is an finite series. You will separate it with the addition. Here you have to separate with the commas. So this is the difference between sequence and series. Am I clear? So in this session, I hope everybody learned about the concept of sequence and series. Sequence is nothing but arrangement, a systematic arrangement of numbers, or you can mention it like a terms which follow some pattern is nothing but a sequence. Am I clear with it? Yes, whereas in a series, all the terms whatever you take in the sequence, that you need to add up here so that you have to get a value of series. Right? Am I clear? So you also have learnt about Tn, means the value of the nth place in an sequence. So usually represented with Tn. I hope everybody are clear with the class. Thank you all. Bye bye.